Good morning, friends. I, Dr. Devesh Bandil, Associate Professor, Suresh Gyan Vihar University, that is accredited by NAC A grade, and that is the first private university who is accredited by NAC A grade in Rajasthan. Today, today I will discuss about how to delete node from BST. Now I am presenting my screen. I hope you can see my screen. Today I will discuss about how to delete node in BST. BST is that binary search tree. When you are deleting a node from BST, from binary search tree, you should know about the binary search tree, and also you should know about how to insert a node in your binary search tree. Okay. And BST, that is your binary search tree. In your tree, one are root node, and your one are left subtree, and one are your right subtree. And as per the rule of your binary search tree, the left node value is always less than from your root node, and your right subtree node value is greater than or equal to from the root node. Today objective is that how to delete a node from a BST, from that is your binary search tree. And during this lecture, I will cover so many topics like your object and outcome of this lecture, overview of binary search tree, representation of binary search tree, basic operations of binary search tree, and main objective of this lecture, write the algorithm for delete the node from binary search tree. And after that, I will implement this algorithm in other programming language like your C and C++. And end of this lecture, I will discuss about some questions which are related from this lecture. And your first topic, as per I had told, I will discuss object and outcome. If we will talk about the object of your DSA, of your data structure and algorithm, so the main objective of your data structure algorithm is that to emphasize the concept of your algorithm, to emphasize the concept of your stack, linked list, tree, searching, and sorting. And if we will discuss about the outcome of this lecture, outcome of DSA. So after studied the DSA, student will able to how to write the algorithm, how to implement the algorithm in any programming language like your C and C++. Also, student will able to how to use the stack, how to use the queue. What are the examples of queue? What are the examples of your stack? What are your searching techniques? What are your sorting techniques? How you will use the graph? How you will choose the minimum path? These are the all outcomes of your DSA. And now if we will talk about the object and outcome of this lecture, the main objective of this lecture to understand the concept of your binary search tree, and also should understand the concept of how to delete the node from your binary search tree. You know, as per I had told, in your binary search tree, you can insert the delete the node from the binary search tree. And here I will discuss about how to delete the node from a binary search tree. And if we will discuss about the outcome of this lecture, the main outcome of this lecture Student will learn about the how to write the algorithm for delete the node from binary search tree from BST, and how to implement algorithm in any other programming language like your C and C++, whatever you want. And now, as per I had told your object, understand the concept of your delete a node from BST, and outcome how to delete the node from the binary search tree. And as per I had told, if you are deleting a node from the binary search tree, so you should know about what is your binary search tree, how to insert the node in your binary search tree. And in this lecture, I will main focus on your how to delete the node from your binary search tree. So in your binary search tree, a binary search tree, that is your BST, in which all the nodes follow the below mentioned property, like your the value of the key of the left subtree is less than the value of parent nodes key. As per I had told, the left subtree node value is always less than from your root node value. And another property of BST, the value of the key of the right subtree is greater than or equal to the value of your parent's nodes key. And BST, your BST, all its subtree into two segments, the left subtree and your right subtree. And also, if you want to define in your mathematical term in your one statement, so your left subtree less than root and less than equal to right subtree, because as per I had told, in your binary search tree, left subtree value is always less than from your root node, and your right subtree value is greater than or equal to from your root node. That's why you can write in your mathematical statement, your left subtree value is less than root node, less than equal to right subtree. As per you can see, left subtree less than node key less than equal to right subtree. So these are the all property of your binary search tree. If you will follow this property, means you can make the binary search tree. And now, you know how to represent your binary search tree. As per I told, binary tree is a collection of your nodes arranged in a way where the maintain the BST properties. And what are the BST properties? As per I had told, each node a key and an asset value. While searching, the desired key is your compared to the key in your BST. And if found, the asset value is retrieved. And now, here your representation of BST. Here I had not mentioned the image, because as per the manner of your understand, when you will represent a BST, okay. So in your BST, your left subtree value is always less than from your root node, and your right subtree value is always greater than from your root node. That is the representation of your binary search tree. And if we will discuss about the basic operations of your BST, of your binary search tree. So there are many operations of your BST. First operation is that your search. Search, you know, when you want to search the any node in your tree, that is your searching operation. Okay. If you are searching the any node value in your tree, so first of all, your searching key value will start from your root node. Okay, if your searching key value is not uh, equal to the root node, and that time you will search your searching key value. If your searching key value is less than from your root node, so you will go into your left subtree, and if your searching key value is greater than or equal to from your right subtree, from your root, sorry, so you will go into your right subtree. And always initially you will start from your root value. Okay, and always you will focus in your searching operation. If your searching key value is less than from your root value, you will follow the path of your left subtree, and if your searching key value is greater than from your root node or equal to, so you will always follow the path of your right subtree. And after that, your another operation is your insert operation. Insert, from the name you can understand, insert means when you will insert the node in your tree, as per like when I had talked about the queue, when I had talked about your stack, and in your stack you can also insert a node, insert a element in your stack, and also you can insert a element in your queue. Okay, and here you are inserting the element, inserting the node in your tree. That is your insert operation when you will insert a node in your tree. When you will insert the value in your tree, that is your insertion operation. Okay, and after that, two remaining operations of your BST is that pre-order traversal, in-order traversal, in post-order traversal. I had I had already discussed about the insert operation, pre-order traversal, in-order traversal, and your post-order traversal in my past lectures, and that's why I hope there is no need for describe these operations of your BST, but here I am giving the overview of these operations, because if you don't know about this operation, you can't delete the node from your binary search tree. And your pre-order traversal, in your pre-order traversal, if you will traverse in a pre-order manner, that is your pre-order traversal. And if you will traverse in ordered manner, that is your in order traversal. And if you will traverse a tree in your post order manner, that is your post order traversal. Basically, these are the five basic operations of your BST as per I had discussed: search operation, insert operation, pre order traversal, or in order traversal, and your post order traversal. And here I am describing, define a node. When you will insert a node in your BST, when you will deleting a node from the BST, you should know how to create a node. If you are not having a node, means you can't insert the node in your binary search tree. Okay, so defining a node having some data, reference it to its your left and your right child nodes. Okay, but you will create the node for your root, you will create the node for your right subtree, and also you will create the node from your for your right subtree. That's why here I am discussing about the node, how to create a node. When you will create a node, your node will be create through the structure through and your struct is the keyword of your structure. And your node will have the data, and as per your tree, you will take the two pointer. First is your left child pointer and second is your right child pointer. So here I have to create the two pointer. First is your left child pointer and second is your right child pointer, as you can see in my given slide. And now I will discuss about the insertion operation on your BST, how to insert a node in your BST. And whenever an element is to be inserted, first your aim locate its proper location where your new node will be inserted. And start always you will start from your root node. Always your searching will be start from your root node. Okay, and if your data is less than the key value, all search for the empty location in your left subtree. If your data is less than from your root node, so you will follow the left subtree path from your root node. And if your data is greater than the key value, so you will search for the empty location in the right subtree from the node, and you will insert the data. Otherwise, search for the empty location in the right subtree and insert the data. So you will insert a node in your BST if your searching value, if your inserting node value is less than from your root node. So you will choose the left path from your root node. If your value is greater than or equal to from the root node, so always you will choose the right subtree path. You know your searching will start from your root node. And now here I had mentioned a algorithm as per your instruction. Algorithm, your algorithm is just write the instructions step by step instruction for achieve a goal. This is your this is the way of your algorithm. There is no any fundamental concept. Okay, first of all, always you will write this instruction. After that, always you will write this instruction. After that, you will write the instruction. There is no any fundamental rule. Always when you want to write the algorithm for any technique, always you will write the step by step instructions. You first in your instruction this will happen, in your second instruction this will happen, in your third instruction this will happen. This is your algorithm. And here I am writing algorithm for your insert node. Create a node, BST node, and assign value to it. First of all, you will create a node and you will assign the value. Okay, and in your second step, you will make a function of insert name, and you will take the two parameter node and your key. And if your root equal to null, means return the new node to the calling function. Okay, and in your second step, if data is less than from your key, so call the insert function with uh, root will access to the right and assign to the right value in your root, right. Okay, and always, and you will insert the value in your right subtree. And if your data is greater than from your key, to call the insert function root equal greater than left, and assign the return value in the left. Okay, now this is the algorithm when you will insert a node. And finally, return the original root pointer to the calling function. So when you will write the algorithm for any technique, only you will just write the instructions only step by step, and that is the algorithm. And here this is the implementation. You can see it will handle two cases. First, suppose if your tree is empty, return new node in the root. Suppose if your tree is empty and you are inserting a node in your BST, obviously your new node will be insert in your root if your tree is empty. Okay, and in your second, if your tree traversal which is null, it will return the new node. if the given value is greater than the root key. Okay, and we should find the correct place in the right subtree and insert the new node. So always only one key point when you will insert a node in your BST. So your if your inserting key value is a inserting node key value is greater than from your root, so always you will choose the left path. Is that right path? And if your inserting node value is less than from your root node, always you will choose the left path. That is your fundamental concept of when you will insert the node in your BST. And here this is the implementation. You can see in your I had mentioned it message. First, prevent the duplicate nodes in the tree. In your first step, in your second step, in your first step, if your key equal to the value, it will straight away return the address of your root node, and after the insertion, it will return the original unchanged root's address. As per I had mentioned. And this is the diagram when you will delete the node from your BST. Your first image, and this is the image before deleting 7. Okay, and after deleting 7, your image will be this. You can see here. If you will follow the in-order traversal, your in-order traversal, first of all, you will visit the left subtree. After that, you will visit the root, and after that, you will visit the right subtree. If you will follow the in-order traversal, and if you will follow the pre-order traversal, in your pre-order traversal, first of all, you will visit the root node. After that, you will visit the left subtree. After that, you will visit the right subtree. And if you will follow the post-order traversal, in your post-order traversal, first you will traverse the left node. After that, you will traverse the right node, and after that, you will traverse the root node. Means in your post-order traversal, your root node will visit in your last node. So here I had mentioned the two images. Your one image is before deleting 7 node, the 7 node value, and second image after deleting the 7 node. Here you will follow the in-order traversal. So in-order traversal, first of all you will visit the leaf node. Sorry, you will visit the left subtree. That's why you will start the 4. Okay, 4 5, and after that you will visit the 7. After that you will visit the 11, 13, and your 19. You can see here, and I hope you know about when you will follow the in-order traversal. And after deleting the 7, your new image will be, you can see 4 5 11, 13, and 19. This is your when you have to delete the 7 from your root. Okay, here you can see in both properties I had followed the path according to the in-order traversal, and already I had told about the what is the order of your in-order traversal. And now this is the algorithm. Okay, first of all, input the number of nodes. Input the nodes of the tree. Consider the first element as the root element and insert all the elements. Input the data of the nodes to be deleted. Okay, this is the algorithm, and I had written this algorithm step by step for achieving the goal. Okay, as per in your step, first input the number of nodes, means how many nodes you want to take. So input the number of your nodes, and second input the nodes of the tree. and consider the first element as your root element and insert all the elements, and in your fourth step input the data of the node to be deleted. If the node is a leaf node, delete the node directly. If your node is a leaf node, so you can delete that directly. Leaf node your leaf node are those nodes who have no any branches, no any left subtree and no any right subtree. That is your leaf node. So if the node is your leaf node, delete the node directly. Else, if the node has one child, copy the child to the node to be deleted and deleted the child node. Else, if the node has two children, find the in-order successor of the node. Means you will follow the in-order and copy the content of the in-order successor to the node to be deleted and delete the in-order successor. So this is the algorithm for delete the node from your BST. And now this is the implementation of your delete a node. You can see here. This is the implementation in your C language. And sorry, you know, you can implement in any programming language like your C, C++, and any other language. There is no any foundation key. You will just implement only this language, only this language. There is no any foundation. You can implement technique in any other programming language, whatever you want, like your C, C++, Java, Python, etc. So here I had implemented in your C language. So first of all, you will create the node, and I had already discussed about how to create a node. You will take the data, you will take the two pointer. First is for left pointer, and second is your right pointer, and you will function to create a new node, struct node, new node, struct node temp, and struct node malloc. Through the malloc function you can allocate it the size for the node, and your item will assign into your data. And you can see here, and this is the remaining part when you are implementing the deleting a node from a uh, by BST. You can see here. Here I am not describing the implementation because I had already described the how to write the algorithm, and only when you will implement the algorithm, only you will follow the syntax of only programming language, and always you will follow the concept from the algorithm, from the instructions which you have already written in your algorithm. And this is your in order. This is your in order implementation. And this is the example of your searching operation. I had already told about that when your searching will always start from the root node, and compare the searching element with root. If less than root, the recurs for left, else recurs for right. And if the element search is found anywhere, return the true, else return the false. This is the example of your searching operation. And you can see here, this is your tree. And here I had followed the all properties of your binary search tree. Okay, like that. Six is your parent node, and 4 is your left subtree, and 4 is the value is less than from your 6, and your 7 is your right subtree, and the value is greater than from your root node. And also you can see here, 1 is the left subtree from the root node 3. The value of 1 is less than from your from the node 3, and the 6 is your right subtree, and this value is greater than from your root. And this is the example I am discussing about, the example of your insert key. A new key is always inserted at the leaf node. As per I had told, when you will insert the any key, always your key will inserted at your leaf node, because your leaf node not have the left subtree and not have the right subtree. Always your new key is always inserted at your leaf node. Okay, and we start searching a key from the root until we hit a leaf node. Once a leaf node is found, the new node is added as a child of the leaf node. And here I had mentioned the in order traversal, pre-order traversal, and your post-order traversal. And in order traversal method, first of all you will traverse the left subtree. After that you will traverse the right subtree, and after sorry first of all you will traverse the left subtree. After that you will traverse the root node. After that you will traverse the right subtree. And you can also see here in this image. First of all, you will visit the left subtree, that is your B. After that, you will visit the root, that is your A. After that, you will visit the right subtree, that is your C. You can see here, and also you can see here, this is the path, and in this path we have follow the in order traversal. Like you can see here, you can see here D B E A F C G. D B E, you can see here a path D B E A F C G. And this is the algorithm for your in order traversal. Recursively traverse the left subtree, root node, and recursively traverse the right subtree. Pre-order traversal, first of all you will visit the root node. After that you will visit left subtree. After that you will visit the right subtree. You can see here. And also you can see here how to traverse the industry in your pre-order traversal. And also you can select the path as per your pre-order traversal. And you can see here I had mentioned the algorithm for your pre-order traversal. Visit the root node, recursively traverse the left subtree, recursively the traverse the right subtree. And this is the last operations of your BST, post-order traversal. In this traversal, the root node is listed the last, hence the name. First we traverse the left subtree, then the right subtree, and finally the root node. And also you can see here in your post-order traversal, first of all you will visit the left subtree. After that you will visit the right subtree. After that you will visit the root node. First of all, you will visit the left subtree B. After that, you will visit the right subtree, that is your C. After that, you will visit the root node. And you can see here, this is the path. And I had mentioned the algorithm for your post-order traversal. As per I had told in your post-order traversal, in your post-order traversal, first of all, you will traverse the left subtree. After that, you will traverse the right subtree, and after that, you will traverse the root node. Means root will be traversed in your last board, in your order traversal. And where if you will follow the in order traversal, so first of all, your root node will visit at your first level, and okay, and now Here is the tree, and this is the in-order traversal, pre-order traversal, and or post-order traversal. Also define the procedure when you will follow, when you will traverse in your in-order manner, when you will traverse in your pre-order manner, when you will traverse the post-order manner. Like your in-order traversal, left, root, right; pre-order, root, left and right; and your post-order, left, right, and your root. And as per I had told, end of this lecture, I will discuss about the some questions which are related from this lecture. This is your tree, and you can see here I had followed the all property of your binary search tree. Okay, like your fifth value. Your fifth value is already inserted in your right subtree. Okay, and the property of your BST, the right subtree value is always greater than or equal to the root node. And also you can see here your 11 value I have to insert it in your right subtree because 11 is the greater than from your 7. And also you can see here your 9 have to be placed in your right subtree because this value is greater than from your 5. And as per the question, you will find the in order traversal. So, in order traversal, first of all, you will visit the left subtree. After that, you will visit the root node. After that, you will visit the right subtree. So as per in order traversal, you can find the path. Here, are given four options. First is your A option 62571112594. B option 652117495. C option 27265115594. 27651129554. So here I am following the in order traversal. Okay. So in order traversal, first of all you will traverse the left subtree. Okay, and if you will see here in your C and D option, your first node is your 2. And you are following the in order traversal. So your first node is always starting from your left subtree. Okay. And your left subtree is your 6. That's why your C and D answer impossible. Okay, because in your C option and D option, your first value is your 2, and that is not a left subtree value. Okay, that's why C and D both options are incorrect. And now you will find the path as per your in order traversal from your A and B. Okay, so in your A 625, 625, because in order traversal you will first of all you will traverse the left, after that you will traverse right, after that you will traverse the 5. Okay, so 625. And in your B option 652, so this option is not possible because here your sequence is your 652. And in your 652 means 6, 5 and 2, that is not possible. That's why your answer will be your A answer: 62571112594. This is your in order traversal. And now your another question. Here as per given, I had given the and which of the following graph traverse closely imitates level order traversal in your binary tree? Depth first search, breadth first search, depth and breadth first search, and your binary search. You know, when you will traverse the graph and when you will traverse the all nodes of your graph, imitates level order traversal of a binary tree, that is your breadth first search, that is your BFS. That's why your answer will be your B answer. Okay, because your question is that which of the following graph traversal closely imitates level order traversal of your binary tree. So always breadth first search graph traversal closely imitates level order traversal of your binary tree. And now next question is that a person want to visit some places. He start from a vertex, then want to visit every places connected to the vertex and so on. So what algorithm he should use? If you will start from a vertex and you want to visit the every places connected to the vertex and so on, so you will always follow the breadth first search, because in your breadth first search you will start from a vertex and then want to visit every place connected to the vertex. So your answer will be your B answer, breadth first search. And which of the following is not an application of your breadth first search? Finding shortest path between two nodes, finding bipartitionness of a graph, GPS navigation system, and your path finding. Okay, and finding shortest path, you will find the shortest path. This is the application of your breadth first search, because in a breadth first search you will find the shortest path. So your A option is not correct, because as per your question, you will find which of the following is not an application of your breadth first search. That's why your A option is wrong. Finding bipartitionness of a graph, this option is also wrong. GPS navigation system, and in your GPS you will find the shortest path. That's why your answer this is wrong, and your path finding. So your D option is right. Right, path finding is not an application of breadth first search. Means if you will find the path, so you can find the any path, either your long path and either your short path. And through the breadth first search, always you will find the shortest path. And another question is that regarding implementation of breadth first search using queue, what is the maximum distance between two nodes present in the queue? Considering each edge length is 1, can be anything 0, at most 1, and your insufficient information. So your answer will be your C answer, at most 1. And the last question is your, in BFS, how many times a node is visited? Once. First option is your once, second option is your twice, third option is your equivalent to number of in degree of the node, and fourth option is your thrice. So in BFS, how many times a node is visited? Your once, twice, equivalent to number of in degree, and your thrice. So your answer will be a C. No, only one time a node is visited, twice time a node is visited. Your node is visited as per equivalent to the number of your in degree of the node. That's why your answer is your C answer. Not a once, not a only one time a node is visited, not a only two time a node is visited, not a three time a node is visited. Equivalent to the number of in degree of the node. That's why your answer will be your C answer. So in this lecture, I had discussed about your concept of your binary search tree, concept of your basic operations of your binary search tree, and how to insert a node in your binary search tree. And in this lecture, mainly focus how to delete a node from the binary search tree. Because if you can insert a node in your binary search tree, also you can delete a node from the binary search tree. And mainly focus in this lecture into how to delete a node from the binary search tree. And also in this lecture, I had discussed about a pre-order, in-order, and your post-order traversal. I hope you have understood this lecture. Thank you.